Good day, everyone. We are here to discuss to you our case study, which is diminishing non-conformities of the finished electroplates with regards to its thickness during quality check. So we conducted a study in Tayo Yuden, which is a leading manufacturer of capacitors, inductors, circuit products, RF devices, energy devices, and more. So with the help of our mentor, engineer Charlene Tungala, we asked her a current problem that the company is facing right now relating with industrial engineering program. We conducted a study focusing on a problem that needs a solution to eliminate waste, which are defect, overproduction, waiting, not utilizing talent, transportation, inventory excess, motion waste, and excess processing, or we call it downtime. In our case study, we have a data with 20 samples a day to be randomly checked by the quality officer. Using a 30 days data, the quality analyst, Engineer Tungala, found out that the average nonconformities with regards to electroplates thickness per day is below its control limits. But before we go further with the case study, I will define to you first what is nonconformity and why is it a problem. So according to ISO 9001, the international standard for a quality management system, nonconformity is a failure to meet the standards and requirements. The possible reasons why it exists is because of miscommunication, lack of documentation, limited training of personnel, less motivation of personnel, inappropriate quality of materials, tools, and equipment, and dysfunctional operating environment, or it could also be because of the methods that are used are wrong. So this means that it could lead to waste, and so our task is to eliminate it, as it is a problem to our process. We ask also Engineer Tungala what they will do to the products if non-conformities occur. So when non-conformities occur, the product is most probably thrown away by the company. It is such a big waste as it is a profit loss. So the time, people's labor, utilities used during the process, ideas, or etc. will turn into waste if a product doesn't meet the standards. And as we conducted the case study, the company does not have an alternative solution to the problem yet. So we look thoroughly into it and find the best possible solution to the problem. And here's Mariela Raguilab to explain furthermore about the case study.
So thank you, Shanaiah, for that introduction. So as you see, the quality analyst randomly checked the finished electroplates with 20 samples per batch using sampling per lot. Utilizing the given data of 3-day quality checking, it has been found out that the average nonconformities of electroplates thickness is out of control. Here is the sample of the given data. So as Shanaiah said, there are 20 samples per batch. So per batch is there are 10 samples made per batch. So that is 10 times a day. So they started on June 9th up to the June 11th. So we propose to use control charts to determine if the process is in control or not. It is to also check which batches is beyond the calculated control limits. So the plant has already a designated control limit that they have. So for the lower limit, they set it as 7. For the upper limit, it's 15 and 11 for the central limit. So this is how it is depicted. So it's just the same data as before. It's just that we added the lower, upper, and the central limit. So in graph, it was seen that the batches made on June 11th were out of control or did not pass the quality check. So a total of 200 units of non-conforming electroplates. So this is the control chart. So this area is where it went out of control. So those data are below the lower control limit. So to find the actual root of these batches, we use a Six Sigma tool called Diminishing. So DMIC stands for define, measure, analyze, improve, and control. So the first step is to determine the problem. So we determined that during June 11th, all the samples gathered were out of control limits. So as you see, we have 15 as the upper limit and 7 as the lower control limit. So during these days, as you will see here that the thickness were below the control limit. So it's around 5 to 6. So the second step is to measure. So by creating a control chart, we can distinguish the control limits and check the data if the process is in control or not. So it was calculated that the designated lower control limit is 7, the central line as 11, and the upper control limit as 15. So if we plot the averages during that day are out of control. So this is the data that were out of control. So the third step for the mic is analyze. So the control chart shows the samples made on June 11 were below the designated control limit of 7. The total non-conforming units made were 200 units for this day. Since electroplating requires a high level of diligence, experience, and precision to do correctly, it is dependent not only on the exacting specifications of the electrochemical process, but also on a thorough prep job being completed before the switch is turned on. So as a result, electroplating is host to several defects due to the complexity of the process. So there are actually two major different methods in checking the quality of electroplates. That will affect the thickness of the electroplates. So these are the destructive method and the semi-destructive method. So under the destructive method, we have the microsectioning of the plates that leads and examining them microscopically to measure thickness. So this is very time consuming and is used only for confirmation in cases when there is a dispute in thickness reading obtained. So the other method is a semi-destructive method, which is by testing the thickness by chemical stripping. So Engineer Tungala confirmed that this is actually the method that they are currently using, which is in Tayo-Yuden. So this sample preparation, which is the chemical stripping, is to mask after finishing, and they strip part of the coating to be measured to the layer underneath, making sure that the basis material surface is undistributed by the stripping operation. The test panel is then observed with interferometer to measure the difference in height between the finished and unfinished areas. Usually, when any light is reflected, it undergoes a slight phase shift, the magnitude of which depends upon the material reflecting the light. For instance, there's a difference in optical properties between two different metals and a slightly greater difference between metals and plastics. This phase creates an uncertainty in measurement. So the word uncertainty pervades of all the literature concerned with thickness testing. So it actually means that the amount of deviation of or margin of error to expect from measurement. So thus an uncertainty of plus minus 10% is greater than one of plus minus 5%. So the lower the figure means that there is more accuracy to the measurement. So how do we improve their current process? So we look into options into how we can minimize or diminish their non-conformities in electroplating. So the most effective way to check electroplates with the less probability of a non-conforming units because of their thickness is X-ray fluorescence method. So it is a non-destructive and non-contact layer thickness and material analysis of metallic coated materials to DIN to DIN EN ISO 3497. So this measuring technique enables us to define the layer of thickness and compositions of individual layers, multiple layers, and alloyed layers. So it is possible to measure coating systems with up to 3 layers at the same time, or simultaneous measurement of thickness and composition of layers having up to 3 integral components. So what are the advantages of the process? So first, virtually no restrictions on part geometry. Second, accurate positioning of the measurement point. Third, very small measuring area. And then lastly, little time required. So unlike the two processes, which is the destructive and non-destructive, this is actually more time efficient. So using this kind is the most effective and efficient way in testing electroplate samples that is non-destructive and will lessen the non-conforming during quality. So the last step is control. So through X-ray fluorescence method, we possibly eliminate or diminish the non-conformities of electroplates thickness. So to execute such, the company should enhance their equipment and process to put this method into work and can save them a number of defects and the cost of non-conforming electroplates that they don't reuse or recycle. So to
Okay.
conclude, we'll get back to Shanaiah.
So as we studied the problem, we figured out that the method used by the company is semi-destructive, which causes the occurrence of the nonconformity. So we recommended to change the method that could diminish or eliminate the electroplate's nonconformity, specifically its thickness quality. X-ray fluorescence method is non-destructive, which made it to be the best alternative solution. It could save the product from being thrown away. If this is the method that will be used, it will give a big help to the company. X-ray fluorescence method will stop the nonconformities from reoccurring. And to sum it all up, our team, conducted a study in Taiyudan and found out that the electroplate's thickness on June 11 is below the designated control limits. It is because the method they are using is semi-destructive, which made the nonconformities to occur. With our further research, we found an alternative solution to the problem. We recommend the company to use the X-ray fluorescence method as it is a non-destructive method that could diminish nonconformities. If the company will apply the method we recommended, it will surely help the company to solve the problem regarding the electroplate's thickness nonconformity occurrence.